Good day, students. Today we're going to look at a solution to example 3, part of your turn type of questions in your D2L ANOVA notes. ANOVA meaning, of course, analysis of variance. And this is an example of one-way analysis of variance. We're only looking at one factor. The problem reads, a real estate developer is considering where to place a new mall in Qatar. He has 3 different pieces of land now available to him. One in Al Rayyan, another in Al Wakra, and a third in Al Khor. He wants to make his choice based on income of families in the 3 different areas. A random sample of 7 families living near each piece of land is taken and their total income is listed below. At the 0.05 level of significance, can the developer conclude there is a difference in the mean incomes of each area? Okay, so as you can see, the table has listed in Al Rayyan 640 will be one example, but that's 640,000 now. It's in thousands of rials. So each one has 3 zeros past it. So 640,000 rials. That's one family's income in Al Rayyan. And you'll see to the right of the table an example of an F distribution named after the gentleman Fisher, who first to use this type of distribution. And in the F distribution, you can notice it's positively skewed, so all the F values are positive, and it's always a right-tailed test. Okay, and the line that divides these areas, as you can see, the rejection area in red, and the line that divides it, this line right here, let me change the color, let's go to blue. This line right here is the F critical value, and I'll refer to that as FC. So FC for F critical. So the critical value, as you did in another hypothesis testing, divides the rejection area and the do not reject or accept area, right? So the green would be do not reject the null hypothesis or accept it, in other words, and rejection area is in the red. So anything greater than that critical value we're going to reject. Now, in order to run this distribution, let's go through this test. Let's go through the 5 steps of hypothesis testing. Now, the very first step, step 1, is the same whether you're doing the p-test, which is probability test, and I'll show you that later in the video, or the f-test. So the first one here is called H0, or null hypothesis. And the null hypothesis states, very simply, that the means are all equal. So we're going to assume status quo, if you would, that the means are equal of the 3 different, and if it was 4 means, I would say equal to mu4 and so on. The alternate hypothesis, or HA, as I like to call it, H1, some books call it, is that one of the means is different from the others. But don't write it as not equal to. Write it out in words. We're not saying they're all not equal. We're just saying one of the means is different than the others, okay? One of the means is different than the others. So let me just write that, different than the others. Okay? So you can write it out in words just like that. Now step 2 of the 5 steps of the hypothesis testing is to find or select the level of significance alpha, but that's really selected for us. It's always an easy little step to write. Alpha in this case is 0.05. Now step 3 is choose the appropriate test statistic. In this case, of course, it's obvious where you're going to use the f-test, right? Now, so we have to look at the F critical. So FC is what we have to find. Now, how do you find a critical value? How do you find this number that divides the 2 regions? Well, it comes from a list of F ratios already calculated for us based on 2 things. The degrees of freedom of the numerator, I'll call that DF1, and the degrees of freedom of the denominator, and I'll refer to that as DF2. Now, the degrees of freedom of the numerator, okay, is K minus 1. Now K is the number of categories or the number of treatments or so on. In this case we have 3 different areas, so that's K. K is the number of categories, okay? Alright, so we have 3 different ones, so K in this case is going to be 3 minus 1 or simply 2. Degrees of freedom of the denominator is the total number of observations in other words the sample size, minus the number of categories, so n minus k. Now the total of number in our sample, we have 3 different areas times 7 in each one, because sometimes they're not all equal. 7 times 3, just add them all up, and of course it'd be 21. And 21 subtract the number of categories, 3, will give us a degrees of freedom of 18 for the denominator, because it's often referred to as an F ratio. Okay. Now, so let's go find that. How do we find that? Well, that's found in a chart in the back of your textbook or the back on most statistics websites. Okay, so here's one example right here. Alright, now if you look at degrees of freedom of the top, the degrees of freedom of the top is numerator, we said was 2, so there it is right there. So we look at that column. And the degrees of freedom of the denominator is 18. So we look at this row. And the intersection of both of those is our answer, of course. Let me just highlight it. Would be 3.55. So our critical value is 3.55. See it right there? 3.55. Alright, so let me just get rid of that chart. So FC in this case, or critical value for F, is 3.55. Okay? Now, that's a very important value. Of course, that belongs up here on our chart. So FC is 3.55. So anything greater, so step 4, our decision rule is what? If the test value, which we'll calculate in a second based on this data, if that's greater than the critical value, which is 3.55, right? So we're up, if it's greater than 3.55, we're up in the rejection area. Then, of course, we will reject the null hypothesis. So our next thing to do is actually find the test value. Okay, F test. Now, how do we do that? We put all the data in our calculators. You've probably done this already. So let's go to Stat. Now you edit, hit Edit to enter the data. Now you notice I've already entered it to save time. Okay, so all the data is entered, and you know how to simply do that. After you enter the data, let's go Stat, go across to Tests, and ANOVA test is the last one. Okay, ANOVA, there it is. Enter. Now you have to tell the calculator where your data is. So the first one is in L1. L1 is above the number 1. So second function 1, comma, second function L2, comma, second function L3. And there we have them. And then, of course, just enter. Now, it'll give you the p-value, and we'll talk about that in a few minutes. But the f value is what I'm interested in right now. What do you notice? This f value. Okay, this f value, so we'll call it f test, remember. F test value is equal to 7.3. Let's round off, 7.38. Now 7.38 is way up here somewhere in our chart, right? On our chart. It's way in the rejection area. So let's just mark it in right here. Doesn't matter exactly. So it's in the rejection area, as you can see. So since F test is greater than F critical, which is 3.55, we are going to reject the null hypothesis. Okay? And rejecting the null hypothesis, alright, therefore means we accept the alternate hypothesis, which means that one of the means is different. Okay, so one of the means is different from the others. So can the developer conclude, see the last line there, can the developer conclude there is a difference in the mean incomes of each area? Yes, he certainly can, because we've accepted the means are different from the others. So at least one of the means is different from the others. Okay, and there's your conclusion. Now, I'm going to do the last few steps again, but using the p-value. Now, when you do the p-value or probability value test, which can be done on all hypothesis testing, you don't need to find a critical value. So it eliminates step 3. However, you still have to enter the data in the calculator and come up with the p-value. Alright? So if I take out, for example, right, if we do it by p-value, we don't need to look at the F distribution anymore. We don't need to look at the critical values anymore. Okay, we do need to find. So basically we're down to 4 steps, right? So we can eliminate all that. So it's a little bit simpler in process, but I like to do it by both ways so you get the understanding of where it comes from. So step 3 now is to find the p-value, and the p-value is right off the calculator. Let's look at it over here again. Okay, p turns out to be 0.004 or 0046 if you want to go 4 decimal places. Now what do the rules about the p-value test say? We're going to get the same conclusion. It says if p is less than alpha, okay, if p is less than alpha, then we reject the null hypothesis and therefore accept the alternate hypothesis. Now, is p less than alpha? If it's greater, of course, we do not reject. But in our case, our p-value is 0.0046, and that's definitely less than 0.05. Okay, therefore we are going to reject the null hypothesis, accept the alternate hypothesis, which means that one of the means, right? So we're rejecting and therefore accepting one of the means is different from the others. Okay, now that's of course a simpler test, and most people, or some people, are now all going to that test automatically because it's simpler. But I did it both ways so you understand the F statistic as well. Alright, so there's your conclusion. One of the means is different from the others. So the developer can conclude that there is a difference in the mean incomes of each area. Hopefully that helps you. Bye for now.